In this segment, we'll talk about using L'Hopital's rule to find the limit of expression which is given to us, and we'll do that through an example. So here is what we're asked to find. We're asked to find out what the limit of sine 2x by 5x is as x approaches 0. And we can see that at x equal to 0, sine of 2x will be equal to sine of 2 times 0, and it will be 0. At x equal to 0, if you look at 5x, will be 5 times 0, and that will be 0. So we have a 0 by 0 expression. So this becomes a prime candidate for possibly being able to use L'Hopital's rule to find the limit. And what L'Hopital's rule says that if f of a is equal to 0 and g of a is equal to 0, and then if f prime of a and g prime of a exist, and then the limit of f of x divided by g of x as x approaches a will be equal to f prime of a divided by g prime of a. So bottom line is that we take the derivative of the numerator, we take the derivative of the denominator, see if it exists. If it exists, then we can put the limit of x approaching 0 on the derivatives of the numerator and denominator, and that's what L'Hopital's rule tells us about x as x approaches a, and we're getting 0 for both the numerator and the denominator. So we have limit of x approaching 0, sine of 2x divided by 5x, and we know that this is 0 as x approaches 0. Then we know that the this limit will be, hey, let's go and take the derivative of this sine 2x. Let's take the derivative of 5x, and let's go and take the limit as x approaches 0 for that. And we know that the derivative of sine 2x does exist, so it'll be 2 cos 2x. We know the derivative of 5x, that's just 5, and we'll take the limit of x approaching 0. Now in this case, what we have is that if I put x approaching 0, I'll get 1 here for cos of 0, and I'll get 5 here. So that means that we don't have a 0 by 0 case, or 0 by infinity case, or infinity by 0 case, or infinity by infinity case. So we can safely apply these limits. So cos 2 of 0 divided by 5. So this one is 2 times cos of 0 is 1, and this is 5, and that's 2 divided by 5. So the limit of this expression as x approaches 0 is equal to 2 divided by 5. Now I'm going to show you another way of solving this problem without using the L'Hopital's rule, but that may be advanced, but some of you might be interested in that. So the another method which I'm going to show you is by using the Taylor series. So you may not be using this method when you're taking the actual calculus test or something like that, or an AP calculus test, but it does give us a good view of knowing that, hey, how Taylor series works in this type of problem. So we know that the Taylor series for sine of x is x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial, and so on and so forth. That means that we have sine of 2x given to us, right? So that'll be 2x minus 2x cubed divided by 3 factorial plus 2x raised to the power 5 divided by 5 factorial, and so on and so forth. So if we look at the limit of as x approaches 0 of sine 2x divided by 5x, what we're going to get is 2x minus 2x cubed by factorial 3 plus 2x raised to the power 5 divided by factorial 5, and so on and so forth, divided by 5x as limit of x approaches 0. Now if I'm going to divide by 5x throughout, meaning that I'm going to take this 5x and divide it to the numerator, I'll get 2x divided by 5x minus 2x cubed divided by 3 factorial times 5x plus 2x raised to the power 5 divided by 5x times 5 factorial minus so on and so forth. And this will be limit as x approaches 0 So here I'll get limit as x approaches 0. I'll get 2 divided by 5 here. I'll get 2 raised to the power 3 is how much? 8. So I'll get 8x cubed divided by 3 factorial times 5x. And then I'll get 2 raised to the power 5 is how much? 32 x to the power 5 divided by 5x times 5 factorial minus so on and so forth. And you can very well see that here I'll get an x squared term, I'll get an x to the power 4 term, then I'll get x to the power 6 term. So as x approaches 0, all of these are going to become 0. Because this is x cubed, this is x, so I'll be left with x squared, this is x to the power 5, this is x, I'll be left with x to the power 4. So the only term which will be left as x approaches 0 will be this one, which will be 2 divided by 5. So that's another way of showing what the limit of sine 2x by 5x is. I'm going to get the same answer of 2 by 5. And that is the end of this segment.